front of our packet, you guys got through properties, and we're on to identifying singles and sequences, but we're going to identify singles today. I know that there's a few things back in the beginning that I need to clarify. I've been talking a lot with my colleagues about things like point reflection and some of the carry-on to stuff. So I need to backtrack at some point, but not today. We'll do it through some warm-ups next week. So I still think, Luca, I would think we would still have at least maybe a week of instruction, I think. Maybe test early the following week. Does that make sense? Early the following week. So maybe review, like, not next week, but the week after, review and then test would be my guess. Okay? That's literally a guess. Okay, so let's see. We are on page 20, right? Find page 20. All right. And so our goal today is literally just to be able to look at a single transformation and identify it and describe it. So I want to take a moment, and in the side column, notes for my forgetful self, I want to put some stuff in there. So just kind of as review, how many transformations do we have? How many different transformations are they? What are they? Translation. Dilation. Reflection. Okay, so here we go. Our transformations. Number 1 is translation. Number 2 is reflection. And then this is where we're going to just add 2 bullets. Because reflection can be over a line, which that I think we did really, really well. That's what you have previous experience with. But reflection through, I'm going to spell through poorly, through a point is new and was not taught well. So I need to go back to that at some point. Okay. Then there's rotation. And then there's dilation. Okay. So those are our 4 transformations. Okay. Now we also kind of did another transformation, but it was weird, right? Didn't we do some stretches? Stretch that was not dilation, right? We could stretch it horizontally or vertically. Or I'm going to stop. Or vertical. Okay. So now we're up to 5 transformations. What? Okay. Okay. So remember, stretch was doing just this or just that, didn't make a congruent, didn't make a similar, it was weird. So 3 of those are rigid motions, right? The idea of what is a rigid motion is a big idea. We have to be able to explain it using adult language, okay? And then 1 of them makes similar figures, and that's dilation, okay? Stretches are yuck in all ways. All right, so here we go. Given the diagram below of quadrilateral A, B, C, D, and A prime, B prime, C prime, D prime. In your head, not out loud, can we all do it? In your head, not out loud, describe the transformation that occurred using detail and explain how you know. So I want you to take a moment to analyze the picture. Can you tell which of the 5 things happened? What kind of details do we need? How do you know it's that particular transformation? Are we ready to share any answers? Just even to get started?
It's hard to explain this.
Okay. Josie, what do you got so far?
Translation.
I agree. Does everybody agree that it's translation?
Yeah.
Okay, now what details do we need to say?
Left 7
Left 7
and down 3.
and down 3. That's what we need. So describe the transformation. Translation. Left 7 and down 3. Did anybody accidentally want to do right and up by accident? Okay, so just be careful, right? So you got to pay attention to where you start and where you finish. And this is what I just did on my paper. I only did A to A prime. That's all I did for me for counting. Okay, cool. That is perfect for describe the transformation using detail. Now, how did you know? So there's 2 ways to describe how you know. You can either say why it's not the other stuff, right? Or you can say why you know it's translation. So does anybody have any kind of words you might use?
Slide.
It's a slide, yeah. So when it's a slide, what doesn't it do? It doesn't turn or flip, right? It's not a turn or a flip. What else?
The orientation stays the same.
Orientation stayed the same. That's the letters going around the shape, right? Orientation stayed the same. Great. The other thing that you could say, and this is helpful, is corresponding sides are parallel, right? Do you remember that idea? So as we slide, so corresponding sides are parallel. And that's a guarantee even when you have weird slopes for your sides. So I know sometimes like with a square it's hard to tell, but really like AB has the same slope, is parallel to A prime, B prime. Cool. Okay, so give you a second to think time or what you need. How many of you feel confident that you could write the rule starting with X comma Y? Okay, so X comma Y, and then you do an arrow. We have it in words already. The number 7 needs to be in it, right? The number 3 needs to be in it. What do you got, Ellen?
7x, 3y.
Okay, so 7x, 3y. So you did a multiplication, right? That's going to make it bigger in a weird, but that's ready. Do we learn? We learn from our mistakes, right? Does that make sense to everybody? Okay, what do you want to say, Luca?
I put x comma y other than the arrow, other than parentheses. I said x minus 7 comma y minus 3.
That is correct.
Thank you.
Okay, so for translation, specifically our rules are adding and subtracting. I am really glad though that this came out. The 7, even if it was like negative 7x, negative 3y, right? That's going to make it, it actually makes it do a reversal when it's negative too. It's really kind of wild when it does. And you would have had, let's see, x, you would have had more stretch this way. Okay, so seeing those things helps us understand. Could this be a distractor multiple choice answer? Yeah. So could, I bet you another distractor would have been plus 7 plus 3, right? If somebody misread the directions. Okay, those are all good things to look at. All right, here we go, next part. Okay, I think Sophia already answered this. Did the orientation of the letters stay the same or change? Stayed the same. Stayed. Okay. If that's something you're still don't quite understand what we're talking about, just see me on the side before we go to lunch and I'll explain it to you. All right. Is this a rigid motion? Yes. Okay. So now, teachers have been having a lot of discussion about this because we want you to get full credit. So I'm going to give you some sentences right now that you want to kind of use when you're explaining it. So, is this a rigid motion? So let's go. Instead of it, translation So you name the transformation. Translation is a rigid motion. So you're just repeating. And then I would probably put because corresponding sides and angles are congruent. Okay, so translation is a rigid motion because corresponding sides and angles are congruent. Very good. All right, let's see if we can start this next one. Okay, given the diagram below, state the transformation that maps CLJ, triangle CLJ, onto triangle C prime L prime J prime, and use the properties of rigid motions to explain why they are congruent, why the triangles are congruent. All right. So even though CL is still parallel to L prime J C prime, right? Is LJ parallel to this one? No. Okay, so translation's out.
I know.
Who else knows?
Tyler.
Reflection.
It's reflection. Okay, how do we know? We're going to look at this. How do we know it's reflection and not rotation? What do you think?
Because the triangle's upside down.
Okay, the triangle's upside down. More sophisticated answer.
All the points are like L and L prime are the same distance from the origin,
Oh.
and same with C and C prime and J prime.
This is also true. We're getting closer. I like the idea of equidistant. But I wouldn't necessarily go to the origin because this is not a point reflection.
They have equal distance to,
What am I drawing in right now?
the x-axis.
And that is not a point, it's a line. So they're equidistant from the line of reflection. But even more so, what is the property? If I go from C to L to J, there you go. C to L to J, right? So let's answer the question on the bottom. How do you know that this is a reflection and not a rotation? Because the orientation is not, and you have two words you can choose from. You can either say maintained or preserved. Which word do you guys like better? Maintained or preserved? I like preserved. Is that okay with you guys? Okay, not preserved. Okay, so that's how we know. We haven't talked about this a lot yet, but I liked the idea that Luca was talking about equidistant, because if I were to connect J to J prime like that, this, and I'll just call this point M right here, this segment is congruent to that segment, and this is a right angle. So we have a perpendicular bisector. Right? Remember that phrase? That's a good one. All right, can we finish this last part? So here it says, state the transformation. So what's the transformation? We are doing what? Reflection. How do we describe it? Over the x-axis, which is the same thing as the line y equals 0. We'll just put that in parentheses. That the transformation is reflection over the x-axis. So at this point, saying just reflection is not enough. They always want you to do a description. And the nice thing about reflection is it only requires the name of the line or the point that you're reflecting through. I know point reflection is not everybody's favorite yet. We'll get to that at another day. But here it says use the properties of rigid motion to explain why triangle CLJ is congruent to triangle C prime L prime J prime. Here we go. So new sentence. Triangle CLJ is congruent to triangle C prime L prime J prime. And now we need to name what's going on because reflection is a rigid motion. And the next part should sound really familiar, such that, not that part, the transition is, I chose such that as the transition. I don't know if I have a better one. Such that, this is the part that you need to remember, corresponding sides and angles are congruent. So I'm trying to use the same phrase every time we do this type of answer so that way we can kind of ingrain it in our heads. We want to get full credit for that. All right, so we did an example with reflection over a line. We've done an example of translation. Are you ready to turn the page?
Yes, we are.
All right. So it says in the diagram below, triangle ABC is mapped onto A prime, B prime, C prime. All right, bless you. Determine whether or not ABC is congruent to A prime, B prime, C prime. Explain your response. All right, well, are those two triangles congruent? No. So, but just saying they're not congruent, you still need some proof, believe it or not. Like, you can't just say, oh, he's guilty, right? You have to have the evidence to back up your claim. Or, you plagiarized, or whatever. You cheater. Okay, here we go. So, let's do some things. What transformation has occurred here? You think?
Dilation.
Dilation. Okay, so let's analyze the dilation.
And translation.
Does it look like if I were to connect the lines back, we would start at the origin? No? Well, if we want to check, we would just take our straight edge and do some really light lines. I'm going to do them in a light yellow. And I'm just going to do 2 sets because I want to try to, oh, line segment. I'm on line segment. Let's see if I do it now.
Maybe.
Maybe. And the answer is, yes, it is. Okay. So remember, that's how you can find a center of dilation, right? Using your straight edge and drawing back through it. So you do want to, if you didn't pick up a straight edge, don't run and get one now, but in general, try to remember to pick up those tools every day. Okay? All right, so now let's look at our points. We have A, whoops, that's not a letter. We have A, B, and C. Let's find out those coordinate pairs. So take a moment, just write them down. They're already on the picture. A, B, and C. Okay, and once you've done those, let's go to A prime, B prime, C prime. Write down those coordinate pairs. You have a pass? Have a pass.
272 we came from.
Thank you. All right, I can't mark anything else. You're already marked here. It's all good. All right, we're on the next page. Okay. All right. All right, so these points, let's see. Anybody notice a pattern?
Yes.
Okay. So we think it's dilation.
Yeah.
We know it's dilation. What do we know about this dilation? How do we describe dilation? Luca, what do you got?
It enlarges or shrinks a triangle or a shape.
Okay, so describe this dilation to me. Can you do that?
It grows by a growth. It has a growth factor of 2.
Good. So growth, just drop off the growth. So just say factor, scale factor. Okay, so let's go back here to the beginning. Determine whether or not triangle ABC is congruent to A prime, B prime, C prime. All right, I think we have some proof here, right? So triangle ABC is not congruent. I'm going to use the symbol to triangle A prime, B prime, C prime. So how do we explain that? Because triangle ABC has been, how are you going to finish that sentence? Dilated. And now you got to add not just the scale factor. What else do you have to add to that? What are the 2 things you need to say about dilation? Why did we draw those lines? To find out the what? Yeah, the point of intersection, which is called for dilation, is called the center of dilation, right? Okay, so ABC has been dilated by a scale factor of 2, centered at the origin. So we did use the scale factor both in the X and Y direction, right? So what can we say about the 2 shapes? They're not congruent, but they are, remember what that word is? It's just the tilde. So we can say, however, I'm just going to put it here, triangle ABC is similar. That's our word, similar to triangle A prime, B prime, C prime. And we have a whole unit on similarity, so it's okay that this is still kind of like I'm not sure what we're doing here. But basically, if you have an enlargement or a reduction, the scale factor does not equal 1. Our shapes are going to be similar, but not congruent. Okay, last one. There we go. Which of the following best describes the transformation that maps triangle KRT? And sorry, the T disappeared. Let me put it back in for you. Colors. I need a black. I'm sure you can probably figure it out already. Why aren't you moving? There it is. Sorry. Black. Save. All right, there's T. On to K prime, R prime, T prime. So take a moment, go through the 4 choices, see if you can figure out. Write the answer, what the right answer is. Don't say anything out loud. People have answers. Do we have some gut instincts? Do you think you know?
Okay.
What just point to it. Which one do you think it is?
D.
In the back, do we have answers? Yeah. Is it A? Is it B? Is it C? Is it D?
Yes.
Yes, very good. Okay. So it's D. So now, remember the goal is to determine what transformation has occurred. We did that, but how did you know it was not a translation? How did you know it was not a reflection? Okay, Amir, what do you want to tell me?
It's not translation because if you go 6 to the left, it's not like the same for all.
Okay, so it's not, so going 6 to the left doesn't work. It worked for point R, but not for the other points. That's a great observation. What else can we tell? How else can we tell that it's not translation? What was the thing we wrote on this first question? What did we say? Not, well, orientation tells me that it's not going to be a reflection, right? What did we say? It was up here.
I know,
What do you know, Luca?
because corresponding sides are parallel.
Yeah, so they aren't parallel. So, but I really do like, so I'm going to go back to what Amir said, because what Amir said, if he continues to elaborate, would be perfect. Because you would have to say, even though like R prime moves 6 units to the left, or R moves 6 units to the left, K prime doesn't follow the same rule, right? So that we would just have to give a counter example with your example to, I think, make it stick. But I thought that was an excellent observation. So we know it's not translation. And we can say because the slide is different for all points. I mean, like there isn't a consistent slide rule, or you can say because corresponding sides are not parallel. And then I'm just going to put a semicolon here. Slide rule only works for point R.
I have a question.
Yes.
When you say corresponding sides, what do you mean by that?
Oh, I love that you asked that.
Like corresponding sides not parallel.
Okay.
I mean that, like an example of it.
Here we go. So, and I think actually this is something I did in the video, and I think I did not do it well enough to help us understand. So if I were to look at this image, pre-image, I have side KR. It corresponds to side K prime R prime. So in the video, I talked about lining up the letters like K, R, T, K prime, R prime, T prime, like that.
Oh, yeah.
Okay, so that's how we know which vertex corresponds with each vertex, but I can also use it this way. I can say, oh, side RT corresponds with side R prime, T prime, and you can see that if I were to continue extending those, they would intersect, they would not be parallel.
Yeah.
Okay, that's a great question. I'm really glad you asked that. So we have 3 sets of corresponding sides and 3 pairs of corresponding angles in our triangles. Good question. And then the last thing maybe we should write down, we know it's not reflection, and that was, I think it was Sophia that said it. So it's not reflection because the orientation is the same, right? Is maintained or preserved. Maintained. Good job. And that's this lesson. Our next lesson, which would be on Monday, is putting together sequences of transformations, which could be just one transformation, but more likely 2, possibly 3, or as many as you want it to be. Okay? Let me pass out your practice.